This is Hacker Public Radio episode 3492 for Tuesday the 21st of December 2021. Today's show is entitled Linux Inlaws S01E44. Pipewire Just another audio server think again and is part of the series Linux Inlaws. It is hosted by Monochrome and is about 53 minutes long and carries an explicit flag. The summary is Pipewire Just another audio server think again.
This is Linux Inlaws, a podcast on topics around free and open source software, any associated contraband, communism, the revolution in general, and whatever fancies you tickle. Please note that this and other episodes may contain strong language, offensive humor, and other certainly not politically correct language. You have been warned. Our parents insisted on this disclaimer. Happy Mom? Thus, the content is not suitable for consumption in the workplace, especially when played back in an open plan office or similar environments. Any minors under the age of 35 or any pets including fluffy little killer bunnies, your trusty guide dog, unless on speed, and cute T-Rexes or other associated dinosaurs. This is Linux Inlaws Season 1 Episode 44, Pipewire. Just another audio server? Think again. Due to technical reasons, and Martin knows exactly what I'm talking about, this episode is slightly out of schedule. We will be back to our normal rota as soon as possible and apologize for this slight delay in publishing this episode. Unfortunately, my beloved co-host, Martin Visser, cannot make it tonight, so I'm afraid that the dear listeners and you listening to this episode have to do with just me. But to make up for this, I have a very important guest tonight, a guy called Wim Taymans. I hope I got this right without butchering the last name. For those few listeners who do not know Wim, of course, he's the guy behind something called Pipewire, the successor of something called Pulseaudio, but we're going to go into the technical bits in a while. But maybe, Wim, why don't you introduce yourself first of all?
Yes, hi, hello. I'm Wim Taymans. I'm a Belgian. I'm living in Spain currently. I'm a programmer. I started programming when I was young on Commodore 64. I made some games when I was young in university. And then I started getting involved with a project called GStreamer. So I was the second person to contribute to that. So I got involved with multimedia stuff on Linux and all of that, with GNOME Desktop. Went to a lot of conferences. So I've been doing that for a while, GStreamer. And then 4 or 5 years ago, I was asked to rethink the video sharing, mostly for cameras, from web browsers, but also for screen sharing. And that's how Pipewire started 5 years ago. So it sort of evolved into everything, into a replacement for all of the Linux audio stack. So that's kind of exciting, a little bit more than expected. Here we are.
Similar to 42, the answer to all questions, that's by the sound of it. No, Wim, yeah. But before we go into Pipewire, if you have been working on GStreamer, maybe now is the time to give a short overview for the few listeners who do not know audio under Linux. Maybe now is the time to kind of give a short overview of how this whole stack fits together, starting maybe with Alsa, and then continuing to Pulse and what this GStreamer thing is all about, so that we have a little bit of context before we start to discuss something called Pipewire, if that makes sense.
Yeah. So, at the lowest layer, you have the kernel with the driver. So each audio card has a driver. There's a generic driver for USB cards that comply with the USB standard. for audio. But on top of that, user space applications, they communicate with a library called ALSA. ALSA is a lot of stuff, but in essence, it's a little wrapper around IOCTLs to do stuff in the kernel.
It stands for Advanced Linux Sound Architecture, something like this?
Yeah, yes.
Okay,
yes.
guys, sorry.
So initially it was meant to be everything. It has like plugin architecture and you can link plugins together. And it has like a mixer as well and all kinds of tools. But these things, they are less used these days. So in essence, ALSA is used to just communicate with the driver. And also the plugin system is still useful, as you'll see later. So ALSA, of course, replaced a previous kernel API, OSS. So OSS is not used anymore. It's mostly ALSA.
Open sound system, if I'm completely mistaken, right?
Open sound system, yeah. There is a whole history about how it was in the kernel and then proprietary and back out and then back in.
For the old folks, yeah, I can remember it well when I used to compile my old kernels about 20 years ago. Something like that. But I digress. Sorry, I didn't want to interrupt you.
Exactly. So there were some efforts to try to write a sound server in ALSA itself, but the routing was a bit difficult. So eventually there were other sound servers that came out. So like one of the first one was ESD, if I'm not mistaken, in GNOME. And then there were other projects that were more like a synthesizer infrastructure, like ART on KDE. There were others that never gained really much traction, like MOS. But eventually, a new sound server came, which was Pulseaudio. So the Pulseaudio sits on top of ALSA. It basically talks to the application, takes all the audio from the application, mixes it together, and then sends it to the device. It's fairly simple, but it also needs to do things like moving applications to different devices, hot plugging of new devices. So there's a bit of logic that lives in a sound server. And over the years it has grown, like you can do network transport, send audio between computers using Pulseaudio.
But there's another container called Jack, right? If I'm not completely mistaken.
Yeah, so right around the time, well, a little bit before Pulseaudio was developed, the professional Linux and also was developed mostly by the pro audio people. They lived in a separate group mostly. And they were focused on pro audio, which means like low latency. You capture signals from a microphone, you apply effects and send it back out. Things like that, or like digital audio workstations, mixing desks, these things. And they had their own sound server that did very little, but was all about flexibly routing signals around their apps, their drum machines, and all of that. So the focus was completely different, and they sort of developed independently from each other. And by the time that Pulseaudio wanted to do the desktop things, they already saw Jack, which did something completely different. And then we ended up with two situations, one for pro audio and one for desktop.
So this is one of the reasons why many distributions picked up Pulse as the answer to more consumer-oriented audio approaches, right? I suppose.
Yes, exactly. Yeah. So Jack is very, very narrow focused. You can only use one device, and it has to be. Well, you can do other things, but it's very difficult to configure. It doesn't really do any Bluetooth. It's very narrow focus. It's not very generically useful on a desktop. So Pulseaudio instead is very useful. It does everything automatic. You don't really need to configure much. So that works better in a desktop environment. But on the other hand, Pulseaudio was not designed for the low latency use case of Jack for
Okay.
different reasons. For different reasons. Yeah.
Interesting perspective here. And now, how does this whole GStreamer thing come into play here? The way I see it, and full disclosure, I'm by no means a multimedia expert when it comes down to Linux. I just use the stuff and wonder about the different backends. For example, when I use my favorite music application, which is known as Strawberry. It used to be Amarok, but then I switched over to Strawberry. Clementine came in between, but then Clementine fell by the wayside with regards to Bitrot, so I switched over to Strawberry. But there, for example, I see a GStreamer backend that I normally use, and it works. So maybe now is the time to shed a little bit more light on more user-land things?
Yeah, so we talk about ALSA, we talk about the sound servers, but then on top, on the next layer, is the media frameworks. So what do media frameworks do? They do decode, they read files, they demux things, they extract compressed audio, they decode the audio, and then eventually send the audio to, in this case, Pulseaudio, for example, or for the video to the compositor or X11. So that's the task of the multimedia framework. It's like the gluing of all of those decoders, and possibly also provide a good user interface for applications to do this, to make this possible. So that's what GStreamer is. It's an API to be able to construct these kind of things, decoders and demuxers, reading tags out of it, sending it to the sound server in a pluggable way, so that if you have different sound server, that it automatically selects one and all these things. So that's a multimedia framework.
So it's more like a workflow that allows you to connect different components to each other?
Yeah, different blocks, different functional blocks that you connect together. It doesn't really have to do anything with audio, where an audio server is very full of audio. It can be reading files, reading tags, interfacing with various APIs at the lower levels. So it could be like video capture, encoding, sending it over RTP.
Okay.
So that's a thing that multimedia frameworks do. It's like the big glue for gluing all these components together.
I see. And do you know where the name comes from? As in GStreamer, does that have anything to do with GNOME or?
Yes, so originally it was called GNOME Streamer. So it was built. The first version was from 1998, 99, which is exactly when GNOME started implementing their stuff, and it was actually using also GTK at that time.
I see.
So, and it was built using all of these technologies that GNOME was going to use for their GUIs. It was using that object model, and it was meant to go into the GNOME desktop as the multimedia framework. So it was called GNOME Streamer.
I see.
So that's a bit of history. After a while, we figured it out, but it doesn't really have to be GNOME specific. There's nothing really that we need to do GNOME specific. I mean, we can use the technology, but we can just call it GStreamer.
Okay. Interesting overview now. Given the fact that Pulseaudio has been around for a while, why or how did you come to the conclusion that now it would be time for a new approach, hence Pipewire? Maybe you can shed a little bit of light on the history of the project.
Yeah, so the first version of Pipewire was simply meant to be sharing of a camera, video for Linux camera, and just capture video. And we also had capture video from the desktop for screen sharing. It was all implemented using GStreamer. So that's basically the first fundamentals. But when I started doing the project and I was thinking about things, it became clear, like, okay, I'm actually re-implementing all of these GStreamer things. Um, um, can I not make like an audio server with this? And then I actually built an audio server using GStreamer, but then I got into trouble because GStreamer is a bit too high level for this. It doesn't exactly have the lowest possible latency that you want in such a server. So then I started rewriting those components, and then it sort of evolved into Jack actually. And
Okay.
then I had a Jack, but I also had components that actually made it work like Pulseaudio. So then I sort of ended up something in between, and then I started getting serious about it. Maybe I can actually implement both Jack and Pulseaudio with this new thing. So if you say, how did I get to this? It's more like an experimentation and a logical evolving of the code to where it went naturally. Yeah. There wasn't actually a plan to say like, I'm going to replace Jack or Pulseaudio. It's more like building all of these things. It just came to me once. Maybe I should actually try to do this. And I had to go to another redesign to make this actually happen, because the initial design wasn't suited to do Jack. If you want to do like pro audio stuff, you need to be very, very, very specific and very, very pay attention to all the little details to actually make this work. So, and all little bottlenecks that can cause latency is just not possible.
Yeah, I can recall an interview with Leonard Pottering where he kind of shed some light on the challenges that he encountered when designing and implementing Pulse, and latencies were at the very top of that list. So it came a little bit of a surprise that he actually didn't write this in assembler. I'm joking. But I reckon C would be the natural choice for implementing this in the light that probably Rust isn't ready for prime time here, but you need a performant programming language here, right? So
yeah, but more importantly, even is the design of the communication between the clients and the server, which is what Pulseaudio does not do correctly.
okay,
so that's the big problem. So Pulseaudio's design for the communication between clients and the server is based on a socket, which can be a local socket or a network socket, and the protocol can be sent over the network or over a local, between a local daemon and a client. But that rules out shared memory, if you need to be able to send it over a network. And then the whole protocol becomes much more complicated than it needs to be. And actually getting data from a client to a server is very heavy in Pulseaudio.
So Pulse uses UDP or TCP to transmit the data? I suppose UDP,
TCP.
right? TCP, okay, wow.
Yeah. So, and it's TCP. And like, for example, what you need to do in an audio server is the audio card needs, let's say, 100 samples. You need to wake up that client as fast as you can and tell it, you need to make 100 samples right now. And that thing needs to send 100 samples, and it needs to go as quickly as possible to the hardware card. So what happens in Pulseaudio is that it goes to a couple of context switches of threads, then over a socket, it gets marshaled in a message, then over a thread, then to a client, demarshalled, back to the thread, over the network, back to the other thread, and then to the card. So the path is just very long, and you can't make that work reliably with very small buffers. So Pulseaudio can't go very low latency for that reason.
Sounds expensive, yes, especially given the fact that you're using TCP, because the network stack inside the kernel with regards to TCP is quite heavy in comparison to UDP, because the TCP protocol basically takes care of sequencing and all the rest of it. Something that you don't necessarily need for audio, right?
No, right. So there have been some changes made to put part of the data into shared memory. So that speeds up things a bit, and it mostly actually reduces the amount of CPU usage, popping it all over sockets and stuff. So, but yeah, It's mostly the threading model that is causing bottlenecks in Pulseaudio. So if you compare that to Jack is very simple. Card wakes up, it signals a semaphore, the client wakes up, writes stuff in a buffer, the buffer is in shared memory, it wakes up the server again, server reads from the buffer, and that's it. So it's very quick. And it's very similar in Pipewire now. So the path is super simple. So with that design, you can send small buffers very quickly between many different applications. So this is what you need for Jack-like features, but also for low latency.
So essentially you took the shared memory approach and implemented this for Pipewire.
Yeah, so if you look at the implementation of Pipewire, it's very, very similar to Jack. So it uses a bit more modern ways of doing things, like it doesn't use a semaphore, but it uses an event FDs, because you can pool those on one thread, many on one thread. With the semaphore, you actually have to block things like that. And Jack has like a huge piece of shared memory, like 100 megabytes, where everything goes in.
Okay.
So all clients can basically read from all other clients, right? Which is what you don't want to have in a Flatpak or in an environment where you have to isolate programs from each other. So Pulseaudio uses, yeah.
The usual stuff like app images, snaps, whatever. Yes, I get it.
Yeah. So you don't want your, I don't know where it comes from app, be able to peek at other apps as data, right? You want to isolate that from all the other things, which is something that Pulseaudio doesn't do, and Jack also doesn't do. So the Pipewire is designed to only give the memory to a client that it's allowed to see.
So that's something like security already built in to a certain extent.
Yeah, these applications were written 15 years ago. Nobody was talking about Flatpaks or trying to isolate applications or virtual machines. Barely existed on desktops in that way. So yeah, it's a little bit of a rethinking of all of these things, how they should work in this new world. So,
what other differences are there between the traditional approach, like primarily Pulseaudio, I guess, and Pipewire? What sets Pipewire aside with regards to further architecture and implementation differences?
Yeah, so I think the biggest part is the scheduling bit, which is more like Jack. So you have a very short path to waking up clients and getting moving data around. The thing that is used from Pulseaudio is more like all of the dynamic things and the timer-based scheduling, for example, from Pulseaudio is also in Pipewire. So the way that it's built now is you have Pipewire itself, which actually doesn't really natively support Pulseaudio applications. There is a daemon sitting in between that actually translates Pulseaudio clients to Pulseaudio to Pipewire messages.
Okay.
So I guess it's ripped open. Pulseaudio is ripped open into actually three parts. So you have the core part, which is the scheduling of the audio samples, how it flows from clients to the devices. Then you have the policy, which is separated in a session manager, which are all the rules like where should audio go, how does it need to be configured, where are the volumes stored in a database, and all of these things. And then there's the protocol, which is separated in another daemon. So it's actually pulled out in three parts, Pulseaudio.
And in comparison to that, Pipewire is different?
Yeah, yeah. I mean, it eventually implements all of the features that are in Pulseaudio, but it locates the functionality in different parts and with slightly different implementations. So.
Okay. Just curious, you chose C as the main implementation language, similar to Pulseaudio, I might add. Never mind. I think Jack is implemented in C as well.
C++,
Did you ever
yeah.
C++? Okay, C++, yes. I already learned something new.
Jack 1 is C, Jack 2 is C++.
I'm just wondering, because whenever I meet some hipster colleagues of mine, way younger, I might add, than me, of course, they talk about Rust and other newfangled languages, which have certain advantages in terms of memory safety and all the rest of it. Did you ever consider using something else than C to implement this?
Yes, I tried to learn Rust, but I couldn't get it. I didn't manage to feel comfortable enough to actually implement it in Rust. So I needed more practice.
So, I mean, full disclosure, we did a couple of episodes on Rust, on Rust recently. So I'm a little bit of a hidden closet fanboy, if you want to call it like that. I wouldn't consider myself an expert on Rust by no means, but I'm just curious about the language. What do you consider as the biggest challenge with regards to learning curve in Rust, if you took a look at it? Just curious.
Nothing in particular, so I think that's part of the problem.
Okay.
So you read the thing and then there's like, oh yeah, we're going to do a mute here and we take a ref there. But I don't know. If you're writing program, it's also kind of like the code, it's sort of not so very, it sort of comes automatic. You know, you have an ID and then you say, I need to search in a list like this and that. And with the new idioms in Rust, you need to get like experience with that in order to just write the thing that you're thinking, right? So in Rust, I can't do that. They need more. You probably need to start something else simple, like do some modifications on something existing, build up your Rust experience.
Okay.
I wasn't experienced enough to be able to build this in Rust. So I think that's the main reason.
But I take it you're coming from a C background.
Yeah.
Okay.
Very comfortable with C, so.
Fair enough. No, I mean the one thing. Yeah, the one thing that before I digress any further, the last kind of remark or question on this, the one thing that I find very interesting about Rust is actually the comprehensive ecosystem that comes with it, starting with the standard library, which is really, really rich. Never mind the crates ecosystem, where you can simply, similar to Python or other languages of recent persuasion, let's put it this way, where you can simply pick and choose with regards to the functionality you want to implement. I'm just wondering, on what shoulders is Pipewire standing with regard to third-party code, or is it all written right from scratch?
Mostly written from scratch, yeah.
Wow. Okay.
Yeah. There's nothing reused.
Interesting.
Yeah.
Given the fact that if you describe this as an experiment, quite a few distros, and Fedora, I reckon, is one of them, because 34 picked Pipewire as a Pulse replacement, have adopted this as the standard audio subsystem. Any comments on this?
No comment. So I can say, like, I mean, before Fedora, or before I suggested trying this out in Fedora, I've been running and testing the audio server part for like a year and a half, probably, with some other people. So it's not exactly like out of the blue. When it was suggested to be adopted for Fedora, it was already working quite well. Okay. But what happened is it accelerated things enormously. So it, like when it was suggested in Fedora until it was adopted by Fedora. Things just got rewritten, major subsystems. I think the whole Pulseaudio thing was just written in like those 3 months leading up to the release. It was just like, okay, this compiles and it runs and it seems to run better than it did before. Okay, ship it. And literally in Fedora at the last minute, we patched up stuff. So I was sitting there, oh no, this is never gonna survive the testing of Fedora, right? I mean, you follow principles to develop these things. You test them, but it's always like, whoa, I don't know where this is going. But it's went surprisingly well. So until the last minute, I was sitting there and something has to go wrong. This is impossible. How can this work so well?
People
then,
you heard,
it got adopted, so...
People you heard it here first. World domination by accident.
By accident. Well, accident. It was a lot of hard work, of course, but yeah, these things, replacing an audio subsystem is dangerous. You never know where you're going to end up, right?
Exactly. I mean, it's not something that you do over a weekend being a distro. And if rumor is anything to go by, other distros like Canonical Ubuntu are taking a very serious look at this. I mean, Ubuntu has packages as part of their standard repo packages, so you can simply install Pipewire with a few changes, and with your system deconfiguration, it simply replaces Pulseaudio as it's a drop-in replacement for Pulseaudio. Never mind other Linux distros. So I reckon the acceptance curve is quite steep at the moment with regards to Pipewire.
Yeah, it works out really well apparently. I mean, yeah, no comments. In general, it works. It works.
That's good to hear. Just curious, you're the lead architect and you're the main implementer, I suppose.
Yeah.
How many other people are working on this project? Red Hat or not?
It was in the beginning just me. We have some people from Collabora that wrote Wire Plumber. That's an alternative session manager, which is a bit more powerful than the toy session manager that we ship with Pipewire and that is currently used. And mostly the Bluetooth stuff was written by other people. By 2 or 3, mainly 2 or 3 other people.
So the core team is a handful of people, like 2 to 3 or something?
Yeah.
Okay. Yeah, and they are all employed by Red Hat?
No. It's just me.
It's just you, okay.
Yeah.
Fair enough. Where do you see this project going? Other than world domination, that is.
Yeah. We just keep going. So I think, for example, for the moment, there is the goal of having feature parity with Pulseaudio and Jack.
Okay.
So there's a couple of modules that don't really work yet. And a couple of things that need implementing. So we're going to move through that. But then probably after that is done, we are going to start to think about all the new things we can do and try to redesign some of the audio experience. Like, I don't know exactly. GUIs to configure things, possibly.
There are quite a few nice GUIs for Pulseaudio. For example, the equalizer comes to mind. Any plans for this?
So feature parity, as I said. So then an equalizer is needed. But how this will be implemented, I don't know exactly yet. Or how do we want to do this in general? Like, for example, there is now also Easy Effects, which is native Pipewire. It used to be Pulseaudio. So Easy Effects actually uses the Pipewire native filter plugins to implement a filter chain, and it wraps like existing plugins that are actually coming from Pro Audio space, like LV2 plugins and Lotspot plugins. So there's going to be a bridging of these things, like Pro Audio effects that will be used more. They also come with a GUI that maybe we don't want to show to regular users. They're very fancy and sometimes complicated.
Interesting, because LV2 of course rings a bell in the context of, say, something like Audacity, where you can get a lot of plugins for Audacity coming from LV2 and other spaces. So if you plan to integrate this natively with the Pipewire, you're seriously taking a look at the Pro Audio space here, no?
Yeah, so there's a couple of, like, for example, there's an effect chain in Pipewire that you can load, and you can make like an arbitrary graph of Lotspot plugins currently. So you can build your little effect chain. But you can just run any Jack application on top of Pipewire.
Natively? Wow, okay.
Yeah. So
same
Pipewire
API.
So Pipewire is compatible with Pulseaudio applications and Jack applications. So all Jack applications are dual. You can run on top of Pipewire. You don't need Jack anymore.
Okay. Wow. Interesting. That sounds very, very fascinating, especially if you're taking a serious look at, because I see the kind of the Linux audio space dividing into a pro sector, and the more consumer-oriented stuff like the Ubuntu or the Mints of the world, where you simply take a USB stick and have a system up and running in about 10 to 15 minutes max. Whereas a pro audio workstation requires a lot more configuration here, and hence the difference between something called Pulseaudio and Jack, for that matter.
Yeah. So if you take a Fedora 34, you can just run Katia or Carla and see the Pipewire graph using the Jack API, and see your Pulseaudio apps there and make filters and route signals. And it's all one big audio thing. So it's kind of like a unification. It's not exactly a unification because there's still two different APIs. And they don't exactly know about each other. Or maybe they shouldn't know about each other, but I think part of the future is also figuring out where does this go and how can we bring those closer together. These kind of things. Right?
Interesting. Given the fact that both Pulse and Jack are heavily tied into Linux systems and BSDs use something completely different, I take it Pipewire has been designed and implemented along the same way, or do you, for some wild reason, can imagine actually a port to another operating system outside the Linux space? Or would that be too much effort?
I can imagine it, but I'm not interested in doing that myself. If somebody does that, I'm happy to merge patches. But yeah.
Well, the code base is under a GPL license, maybe BSD?
MIT.
It's even more liberal. Okay,
yeah,
so
it's very liberal.
the BSD people who are out there listening, if you're looking for something really extravagant in terms of sound system, the code base is MIT. Just max yourself out.
Yeah,
along these same.
I receive lots of BSD patches. So
you do? Okay. So is Pipewire already up and running on BSD?
It should, yes. It should.
Wow. Okay. Out of the box. People, you heard it here first. What's next? ZOS? Or Windows or something?
Well, I don't know.
Wim, I'm
what
joking.
Is that?
I'm joking. No, I mean, jokes aside, given the fact that WSL 2.0 now has a full-blown Linux kernel integrated, you could even toy with the idea of running this on Windows, I suppose.
Yeah, I think Pulseaudio runs under that system as well.
So it shouldn't be a big deal.
Yeah, so you can replace the drop-in replacement for Pulseaudio with Pipewire.
If you choose to do so. Another more philosophical question, because similar to Pulse, you're tying very much into the guts of the system. Do you perceive something called System D, especially, for example, in a GNOME context, as the right approach with regards to system management? Because System D, for those people who do not know, listening to this podcast, System D started out as a simple init daemon replacement, but has now captured much more of the user land space, ranging from login session management right up to virtual machine management, all the rest of it. So a little bit of more background. GNOME has, I think a couple of years back, maybe recently, decided to tie in more with Systemd, which, suffice it to say, it didn't make the BSD people really that happy, because GNOME was kind of a serious contender for I wouldn't say a standard desktop on BSD systems, but was used quite a lot, let's put it this way. But given the fact that Systemd only runs on Linux, and if GNOME makes itself more dependent, let's put it this way, on Systemd, that more and more, that makes it harder and harder for the BSD people to adopt GNOME as a standard desktop environment. Any comments on this? Any thoughts about Systemd and the kind of high level of integration that this more and more encompassing ecosystem brings with it? Needless to say, there is, of course, a Pipewire Systemd service unit to start up the whole thing.
Yeah, we use it to start up things. It works for that, I guess. Other people use other systems. Yeah, I'm not, I don't know, I don't really have a lot of opinion about these things. I don't know. So, but what we use from Systemd in Pipewire is very little. And I think the stuff that we can use, I think something like login, it monitors the logins and stuff like that, is handy, because in Bluetooth you can only have one user register Bluetooth services. So if you switch consoles or switch users, they register from one user and register for the other, or else there is no Bluetooth for that user. So, I mean, if that service is there, we can use it, we can make use of it. So, I don't know. If there is another system, we can conditionally compile support for that, and then it works as well.
So you perceive Systemd as that toolbox that it was originally set out to be, rather than the threat, as some people figure it, to the whole Unix philosophy.
Oh no, I don't feel threatened, or I don't think that the Unix philosophy should feel threatened. No, but yeah, I mean, it's getting big, of course. There's a lot of stuff that goes in there. As long as it's separated in separate modules, and you can pick and choose. It's a bit like GStreamer. If you look at GStreamer, it's huge, thousands of plugins, wrapping any library that you can find. So yes, if you pull in GStreamer, you pull in everything almost, according to multimedia, I guess. But it's separated in modules. You pick and choose. You disable the things you don't want. Okay. If you have that flexibility, I don't see a problem really. So for Pipewire as well, so there is a clear separation of three items. Like for example, the actual data transport it doesn't need Systemd. It doesn't need any of those services. It just shuffles data around. There's nothing there. And then you have the session manager, which is probably highly specific to where you're running. So there I can see integrations with GNOME-specific things to get config files and settings from the user, integrate with the control panels, and all of these things.
Okay.
So that's living in a session manager. So the question is, how do you build this session manager for your desktop? Do you have tools to do that? It's a bit like making a compositor with Wayland, right? You have toolkits like Sway or Mutter or KDE.
Indeed.
So you build where you're going to run your stuff in, I guess. So I guess it's the same with Pipewire as well. So I don't really see that we are, at some point we have to choose, or we have to integrate everything with systemd, and there's no way around it. I don't see that future at all.
Interesting perspective. Is there anything that we've missed out on regarding Pipewire so far before we close off the show?
No, well, I think you asked about the future of Pipewire. I think we're missing one big piece.
By all means, go ahead.
Yeah. So it started out as a video framework, but we haven't talked about where video is going, because audio sort of took over and then it started replacing these audio demons. But actually, the original goal was to make video processing pipelines. So for VJing purposes, there's a couple of applications on other platforms that are very impressive to do, like this live video combining and mixing and different apps working together. So I see something like that also being created in Pipewire. It's a whole new thing in Linux because there's nothing like it. So I think that's also interesting to see. Yeah.
So people, you heard it first. For the next big thing with regards to audio and video, stay tuned. Okay, watch this space. And of course, the whole code is available on GitHub, I suppose?
Yeah.
For people who want to check it out. Of course, the links will be in the show notes. Fair enough. We normally, at the end of the show, we normally have something called the boxes. That stands for the picks of the week, where we discuss anything that comes to mind. So if there's anything that has crossed your path, so to speak, in the last week or two that you think it would be worth mentioning, now is the time. Can be anything, a movie, a book, something that you rediscovered recently, really anything goes.
Yeah, I actually learned some new Rubik's Cube tricks.
By all means.
Yeah. I was frustrated with. I've learned to solve the Rubik's Cube when I was like 8 years old.
Before you continue, sorry, we may have younger listeners among the audience who do not know necessarily what a Rubik's Cube is. Can you explain?
How do I explain? It's a cube. It's 6 sides with 6 colors, and now it's like blocks. You turn them, you twist them, and the colors can be mixed up. And the purpose is to twist the sides and the middles until all the colors are where they're supposed to be. One color on each side.
It used to be the latest rage in the 80s, back in the day.
Yeah. So, I was doing there's a technique, the CFOP technique, but the upper layer I wasn't really good at it. I only knew like 2 tricks. So I actually learned the other. Well, I do the two lookup method for the orientation and the permutation. So
I see.
I learned like, I don't know, 16 algorithms is it, or maybe, or 20. So, and now I'm a bit faster. Now I'm happy. So yeah.
So you can solve that puzzle, because essentially it's a puzzle within under a minute?
Yeah, under a minute I can do.
Wow, okay.
So next task will be doing the finger tricks, so that I can do it under maybe 45 seconds, 30 seconds.
Okay.
Yeah.
So
it's that or learning Rust.
I see. So Rubik's Cube's World Championships, watch out for Mr. Wim Taymans, just in case. You heard it here first, people. Okay, my pox of the week is actually make my own kefir. Kefir, for those people who don't know it, is a yogurt-like milk derivative. Is that the word I'm looking for? It's essentially fermented milk, pretty much like yogurt. You can buy the stuff in supermarkets, but if you do it yourself, like yogurt, I'm tempted to add, it doesn't even come close to the stuff that you can buy in terms of you have full control over the process. You can do your own stuff. You can control the level of fermentation. The stuff you can buy in the supermarket just doesn't come near if you do it by yourself. And of course, kefir, coming from Central Mongolia, is probably one of the more healthier drinks rather than processed milk. But that will be my pox of the week. Wim, that has been more than interesting, never mind fascinating. It was a pleasure to have you on the show. I would like to thank you for your time and look forward to having you back in a couple of months to talk about the latest and greatest about Pipewire.
Absolutely. It's a pleasure to be here. Thank you.
Thank you, and cut. Wim, that has been more than interesting, let's put it this way. I learned a lot. And this show is, of course, recorded. It should go out, hopefully, before the year's over. We have a little bit of a backlog with episodes. We are publishing this on HPR. If you've taken a look at the website, you know where to find us, but if I don't forget it, of course, I will send you a mail once it's live.
Yeah, great. I'll keep an eye on it.
And thanks again for your time.
You're welcome.
And cool. Do you have a link for this Rubik's Cube thing?
Let me see.
You can send it to me via mail. That's not a big deal. Yeah. If you find it, simply shoot me a mail. That would be great.
Yeah. I'll send you a link to the one that I used. Well,
Perfect.
I composed my own algorithms from different sites, but just not
Excellent.
going into too much.
Wim, again, dankjewel. I know my Dutch is crap.
No, it's very good.
And my French is even worse, so I won't bother with this. And as I said, keep up the good work and speak to you soon.
Okay, thank you.
Take care.
Bye.
Thanks. Bye.
You are currently the...
This is the Linux Inlaws.
You come for the knowledge,
but stay for the madness.
Thank you for listening.
This podcast is licensed under the latest version of the Creative Commons license, Tab Attribution Share Alike. Credits for the intro music go to Blue Sea Roosters for the song Salute Margot, to Twin Flames for their piece called The Flow, used for the segment intros, and finally to Celestial Ground for their song Sweet Justice, used by the Dark Side. You find these and other ditties licensed under Creative Commons at Jamendo, a website dedicated to liberate the music industry from choking copyright legislation and other crap concepts.
You've been listening to Hacker Public Radio at hackerpublicradio.org. Today's show was contributed by an HPR listener like yourself. If you ever thought of recording a podcast, then click on our contribute link to find out how easy it really is. Hosting for HPR is kindly provided by anhonesthost.com, the Internet Archive, and rsync.net. Unless otherwise stated, today's show is released under a Creative Commons Attribution Share Alike 3.0 license.